Greetings! It's about mid-December. We're out here camping along the lower Illinois River, just a few miles up from its confluence with the Rogue River. We're out here along the river bar, this sea of rocks, and it offers an opportunity to learn a little bit about the geology of southwestern Oregon, especially the coastal strip. And when you look down at the rocks, you can see all sorts of interesting stories. And one of the stories that you can find is such as this sort of conglomerate rock. It's made of millions and millions of little itty-bitty rocks, and there's a lot of them all over the place. You can see it's just like a whole bunch of rounded little pebbles, and pebbles don't get rounded in cases like this just randomly. They have to be tumbled, and so this means these had to have been in water. But was this rock formed by some action here out on the river or in the mountains? No, this actually tumbled down from one of the hillsides or mountainsides or cliff faces. You can see a pretty good cliff right there. And it was formed far longer ago than the river actually flowed through here or even existed at all, because this landscape used to be seafloor, and it's often called serpentine land or soil or rock because of the presence of serpentite. And that makes things kind of greenish. There's a lot of sort of greenish rock, and it'll turn the rivers greenish too. You can find actual veins of green, really cool looking serpentine, or serpentite, I think they call it. But you can also find these conglomerate rocks that definitely were made by the crushing and pressure of what I assume is beach gravel that millions and millions and millions of years ago used to be, way over there, 30 miles that way is the actual coastline. And even, just 10,000, 12,000 years ago, the coastline was even farther out before all the glaciers melted at the end of the Ice Age. But one of the interesting things you can find here is not just evidence of some sort of conglomerate of different rocks, but one of the things you can find is actual direct evidence of it being seafloor. And now, I have scoured this huge area all the way, a good half mile or maybe a quarter mile or a half mile that way. And look, it took me 90 minutes of scouring, looking for any example of it, but I cannot find it. There's one that I found, and it's right in front of my truck in camp. And I'm going to make our way back over there and look at it. But as we go, one of the interesting things you might notice is just the variation of different rocks. There's everything that looks like granite and some of the stuff that's shot through with lots and lots of quartz. And the southwestern Oregon region is known for possibly having gold in it. And there was a gold rush out here. The city of Port Orford in some ways supported miners going up all the different rivers like the Elk River, the Sixes River, the Rogue River up to the Illinois, and far inland even. You can find a good wide mix of all kinds of different stuff. This is much different. Look at the rust on that. So there's metal, and they in fact were looking for things like copper, platinum, and you guessed it, gold. That's why the city of Gold Hill exists. That's why the town of Gold Beach is called Gold Beach, because they found actual placers in the sands of the beach. So it really is a gold beach. And if you look carefully, you can sometimes spot some of these sort of greenish rocks, like these here. These are a little bit greenish. That one's very greenish. This one's a little bit greenish, and I collected a couple in camp. We'll make our way over to the evidence of seafloor here. And the seafloor story of Oregon goes back millions and millions of years, as I may have mentioned in the past, as far east as the city of John Day. Near there is the Aldrich Mountains, and those used to be seafloor like 200 million years ago. So a lot of this evidence of, conglomerate rocks, these were formed millions and millions and millions of years ago, and it's just all crumbling away. And some of these sort of conglomerate rocks are crumbling away on their own, and they're surrounded by a little pile of rounded pebbles, and those are all washed up and rounded by the wave action of where the beach was millions and millions and millions and millions of years ago. And a lot of Oregon was ocean before the Cascades rose up and started to sort of build some land. But there's just so many rocks out here, and they all tell an individual story, such as the quartz. Let's see if we can find one that's kind of shot through with some quartz. There's another one of these conglomerates. There's a lot of sort of shiny flecks in some of these that could be, I would guess, like feldspar, or maybe, pyrite. Where there's pyrite, there's gold. And there's some quartz. And, where there's quartz, there's gold. And quartz is a very important thing to know about. It's comprises a great deal of the Earth's crust, a good 20 or 21% of it. And it has a fascinating attribute that is called piezoelectricity. And if you've ever used a gas grill that has an electric push-button start, that's piezoelectricity right there. When you strike quartz or vibrate quartz, it produces electricity. And so, for example, if you were to get two quartz-bearing rocks and rub them together in a dark environment, you can actually see little flashes forming. That's not sparks of like fire trying to start, that's electricity being released. And that is just so cool to, actually play around and like make electricity by banging two rocks together, rubbing two rocks together. But it also has a reverse effect that is rather interesting and matters to those of us living out here in the Pacific Northwest, just right along the Cascadia subduction zone. Piezoelectricity works both ways. There's also the reverse piezoelectric effect, where if you apply energy to the rock itself, to quartz, it will move or vibrate. And there is actual science that has proven that solar flares and cosmic rays in enough sufficient quantity can actually cause the abundant quartz in the Earth's crust to vibrate and possibly release earthquakes. So during intense periods of solar activity, it could be more propensity for the good old Cascadia subduction zone just out there to let loose and destroy the whole Pacific Northwest. The Willamette Valley, Bend, everything is going to get hit. And then everybody on the coast is going to no longer be there. And even here, we're not that far above sea level here along this river bar. And so when the tsunami surge comes up the Rogue River, who knows, maybe it could inundate this area. I don't know if it would flood it out in much force, but it may just slowly rise up, who knows how far, and wash all kinds of debris with it. There could be stuff from the coast that gets washed up here. But speaking of coast, the one rock I was able to find is this one. And you might go, well, what story does this have to tell us about formerly being the ocean floor? Well, see all those little curlicues in it? Those are not just random sort of crystals that formed. Those are actually shells of shellfish that have been fossilized in this rock. And here's my little collection of sort of greenish ones. The camera isn't picking up the color very well, but these are quite greenish by comparison. I'm going to take my trusty hammer here and see if we can actually see some evidence of shell. I don't know where to necessarily do. Sometimes you can't. There we go. Now we can actually see in here, and you can actually almost make out the ribs on that shell, or here you can see, look at that, the ribs of the actual shell. And so these used to be, see, there's actually some crystal in there too. This used to be under the ocean. You can actually see that the ridges that formed the seashell, especially right there. That's a really great example. You can clearly see it. And you can actually see what is now a stone of a shell. Let's see what this one looks like. This piece went flying. Oh, yep, you can see more of those. Those are the imprints of seashells. And we're so far inland that we're in the mountains and it's like a snowy environment. There's no more coastal layer coming this far. It's freezing cold at night. And so it's very, very fascinating to go, gosh, just walking around this huge pile of rocks can teach you so much, even if you only have a rudimentary knowledge like I do. I'm not a trained geologist. I've never even taken geology in college. I've just kind of picked up things here and there as I go, but it's definitely really cool to come walking out across these river bars in places where there's a complex landscape all around, dropping its evidence all through here. So there's granite, there's serpentite, there's all sorts of stuff that I don't even know what it is, and there's just a broad variation of different stuff. And I highly recommend, look at the super rusty one. That doesn't just get rusty on its own. That's got to have some sort of maybe iron ore in it that's causing it to rust. And that's just like a lot of little indications like that, and little flecks of things glinting in the sun. And so I highly recommend people come out to these places, and you don't necessarily need to collect any rocks, but definitely take a look at them and think about what they mean. Like when you see quartz abundantly shot through them, that actually has a story to tell behind it. Or like this here, this looks like some sort of layered shale almost, and that could happen. And then there's quartz through it. And one of the interesting things, I think, as I wrap this up here, I gotta get lunch cleaned up and kind of get some more water filtered out here. I ran out of water, so I'm filtering some creek water. But one of the things that happens in the ocean, on the ocean floor is not just accumulations of seashells or anything like that. Anything that falls in the ocean ends up on the bottom of the ocean and eventually would become the mountains here. One of those things are meteorites. And you can actually, if you're really lucky, find meteorites in such as like, the rock here basically, and they have occasionally found them. I don't know the term for a meteorite that you find buried in the rock, but they've done hard rock mining in these mountains for a long time, and they have randomly in mines found meteorites, and you're like, that is amazing. That thing fell from outer space and survived the impact with our atmosphere, landed in the ocean, and ended up sinking to the ocean floor. The ocean floor slowly accumulated sediments and then was transported inland by the tectonic action, and then was part of the rock underneath a mountain, and then someone drilled a hole in that mountain and went right to that meteorite and found it. I'm like, that is just the serendipity involved in finding a meteorite buried in rock in a mountain. That is just amazing. So amazing. And we're not that far, just across the border, I think, at what's called the Alta mine, they found one. And they found ones at other places. And, of course, there is the mysterious Bald Mountain meteorite that's somewhere out this way in the mountains. It's supposed to be this huge meteorite that's landed there, and it's loaded with valuable minerals, but nobody's been able to find it. It's out there somewhere, but it's definitely a fascinating thing, and geology can be incredibly fascinating and tell you incredibly important stories about how things were and how things used to be. You won't just find Native American artifacts, from 9,000 years ago when there was an occupation site just down at the forks of the Illinois and the Rogue, but you may find all sorts of interesting things telling you stories from the recent past and the very, very distant past. But got to get back to camp here and finish up some chores, but I definitely want to thank you so much for joining me here for a few minutes on the river bar along the Illinois River to talk about the importance of knowing at least a little bit about geology.